To explain how an alternator creates a rotational cycle and how sine and cosine relate to it, let's break it down. 1. Alternator and rotational cycle. An alternator is a device used to generate alternating current, AC, electricity. The key component of an alternator is a rotating magnetic field, typically created by a rotor, the rotating part, and stator, the stationary part. Here's how it works. Rotor rotation. When the rotor rotates, usually powered by a mechanical engine or turbine, it creates a magnetic field that rotates along with it. Induced current. As this magnetic field rotates within the stator, which has coils of wire, it induces a changing magnetic flux through the coils, which in turn generates an alternating current, AC. AC output. The output current alternates because the direction of the magnetic flux changes as the rotor continues to rotate. The speed of rotation determines the frequency of the AC, and this alternation is essentially a sine wave or sometimes a cosine wave because of the continuous cyclic nature of the magnetic field's orientation. 2. Trigonometry and sine-cosine waves. Now, sine and cosine functions come into play when we talk about the behavior of alternating current and the induced voltage in the alternator. Magnetic field and rotation. Imagine the rotor rotating around a circle. The magnetic field strength at a given point on the stator changes as the rotor spins. At different angles, the strength of the magnetic field will be a function of the rotor's position relative to the stator coils. Sinusoidal behavior. The way the magnetic field varies with the rotor's position, and thus the induced voltage, follows a sinusoidal pattern. This is because, as the rotor rotates, the magnetic flux changes in a way that can be modeled by sine or cosine functions, which describe cyclical motions. Sine function. If you think of the rotor's angle as increasing over time, the magnetic flux through a stator coil might follow the pattern of the sine function. It increases from 0 to a maximum value, then decreases back to 0, and so on. Cosine function. Alternatively, if you start the cycle at a different point, the pattern could follow the cosine function, which is simply a shifted sine wave. The rotational motion of the rotor, combined with the principles of electromagnetism, creates the alternating current, which follows a sinusoidal pattern. The sinusoidal wave is a direct result of this cyclical motion, and the trigonometric functions describe the periodic nature of that cycle. So, to sum up, the alternator uses rotational motion to create a varying magnetic field, which induces an alternating current. The shape of the current follows a sinusoidal pattern, and the functions sine and cosine mathematically describe this cyclical change over time.